Number 1, express each of the following as a single trig ratio. So 2 sine 5x cos 5x. So we just have to look. So 2 sine theta cos theta is just sine of 2 times that theta. Right? So we're going to say A, this is equal to, so 2 sine theta cos theta. So this theta is 5x. And so that's equal to sine of 2 times 5x, which is 10x. So that's sine of 10x. Part B. So cos squared of theta minus sine squared of theta. So where's that? Cos squared theta minus sine squared theta. Well, that's literally cos of 2 theta. That's easy. Part C. 1 minus 2 sine squared. So 1 minus 2 sine squared theta. So in this case, theta is 3x. So cos of 2 theta will be cos of 2 times 3x, which is 6x. Okay. Part D. 2 tan of something. Where's that? 2 tan of something. That's right here. So my theta is 4x. Let's just double check. 1 minus tan squared of 4x. 1 minus tan squared of 4x. Yep. And so this is just tan of 2 times 4x. Tan of 8x. And let's see, 4 sine theta cos theta. 4 sine theta cos theta. Well, we have 2 sine theta cos theta. So I suppose we can rewrite E as 2 times 2 sine theta cos theta. Just break up the 4 into 2 times 2. And then this 2 sine theta cos theta would be your sine 2 theta. So this is equal to 2 times sine of 2 theta. There we go. Part F. So cos squared theta by 2 minus 1. Anything like that? Yeah. So we got 2 cos squared of some angle, 2 cos squared of some angle minus 1. So it's perfect right here. The angle in this case is theta by 2. Alright, so in the answer, so that is the same as just saying cos of 2 times that angle. So cos of 2 times theta by 2, or we can say cos theta. That's just cos theta. So it's kind of interesting. Imagine we have an angle of like pi by 3 or 60 degrees. So the cos we know of pi by 3 is equal to 1/2. Right? Now let's do it as though if we're saying we're saying theta is pi by 3. So if we say 2 times the cos squared of pi by 3 divided by 2, which is pi by 6 minus 1, all of that should equal cos of pi by 3. It's the same thing, right? If we just let theta equal pi by 3. And so this is 1/2, so the other one should be 1/2. So let's just check. Pi by 6, the cos of pi by 6 is root 3 over 2. So cos squared of pi by 6 is root 3 over 2 times root 3 over 2 squared. And then you have to multiply that by 2 and subtract 1. Root 3 over, so 2 times, root 3 times root 3 is 3. 2 times 2 is 4 minus 1. This is 3 over 2 minus 1, which is 1/2. Yeah, it's interesting how that's saying that it works for, that's just that one angle that we tested, but this is saying that it works for any angle that we ever test. Right? So if you know any theta, well then you can find 2 cos squared of that theta by 2 minus 1. It's just interesting that all these things are equivalent. Express each of the following as a single trig ratio and then evaluate. Right. So 2 sine theta cos theta is sine of 2 theta. So this is equal to sine of 2 times 45 degrees, sine of 90 degrees. Sine of 90 degrees is just 1. All right, I'm not going to test them all, but let's just say, 2 sine 45 degrees cos 45 degrees. Just for fun, we'll test this one. And that's equal to 2 times, well, sine of 45 degrees is 1 over root 2. cos of 45 degrees is 1 over root 2. So 2 times 1 over root 2 squared is 1/2, and that equals 1. So sure enough, it's the same thing. Cool. Part B. Cos squared 30, so it's cos squared of something, minus sine squared 30. So that's this one. So it's just cos of 2 theta. So B is just straight up cos of 60 degrees. Theta is 30 degrees in this case, so 2 theta is 60 degrees. And the cos of 60 degrees is just 1/2. Part C. 2 sine theta cos theta. That's this one right here. So it's just going to be sine of 2 times theta. So it's pi by 6. 2 times pi by 12 is pi by 6. And the sine of pi by 6 is 1/2 as well. That's cool. So these are actually equivalent. Part D. Cos squared minus sine squared of something. So that's just cos of 2 theta. So cos of 2 times pi by 12 is pi by 6. Cos of pi by 6 is root 3 over 2. Part E. 1 minus 2 sine squared of theta. 1 minus 2 sine squared of theta. That's this one. So this is just cos of 2 theta. Cos. So here theta is 3 pi by 8. And so 2 theta will be 3 pi by 4. And that is 3 pi by 4. That's 1, 2, 3 pi by 4. Negative 1 over root 2. Okay, and F. Tan theta cos squared theta. Oh, that's not one of these. We're going to have to do a little conversion here. So I know that tan theta, I can say this is equal to 2 sine of 60 degrees over cos of 60 degrees, right? That's the same as tan 60 degrees times cos squared 60 degrees. And one of these coses could cancel. Oh, so this is just 2 sine of 60 degrees cos of 60 degrees, which is this guy right up here. So that's just equal to sine of sine of 120 degrees, and 120 degrees, this is 60, 120, 120 degrees. The sine of that is just equal to root 3 over 2. Use a double angle formula to rewrite each trig ratio. So sine of 4 theta. So let's just say that sine of, this is sine of 2 times 2 theta. And so sine of 2 of something is going to be equal to 2 sine 2 theta cos 2 theta. There we go. So double angle formula. Right? So this is 2 times some angle. And then it's going to be 2. So sine of 2 times some angle is 2 times sine of that angle cos of that angle. Right here. All right, let's do cos of 3x. So part B. All right, there's a lot of choice here actually. I'll just use the first one. So cos of some angle of 2 times some angles. This is cos of 2 times 1.5. Say 3 over 2x. Okay, and that's going to be equal to cos squared of 3 over 2x minus sine squared of 3 over 2x. Now I could have written 2 times cos squared 3 over 2x if I wanted, minus 1. And I could have written 1 minus 2 sine squared of 3x over 2. All right, part C, tan of x. So this is tan, another way of writing that is tan of 2x over 2. That's just x. Or we can say tan of 2 times x over 2, which is equal to, so that's now this, 2 of, so where theta is x over 2, so we're going to get, that's equal to 2 tan of x over 2 over 1 minus tan squared of x over 2. All right, part D, we got cos of 6 theta. It's not 60, it's 6 theta. So cos of 6 theta is the same as cos of 2 times 3 theta. And that equals, well, let's just do the first one. Cos squared of 3 theta minus sine squared of 3 theta. Part E, sine of x. Well, sine of x is the same as sine of 2 times x over 2. So we can say that is 2 sine of x over 2 cos of x over 2. God knows why you'd ever want to make sine x into something so complicated, but that's the job. Okay. Tan of 5 theta, we're just going to call that tan of 2 times 5 over 2 theta. So that is equal to 2 tan of 5 halves theta over 1 minus tan squared of 5 halves theta. Okay, seems like this whole thing was to make life harder on us. Like all those new answers are actually more complicated than the originals. That's okay. Let's go to number 4. All right, number 4. Determine the value of sine 2 theta, cos 2 theta, and tan 2 theta, given that cos theta is 3/5 and theta is in the first quadrant. All right, let's do that. Let's show the first quadrant, and cos of theta is 3/5. So the hypotenuse is 5 and the adjacent is 3. This is going to be 5, the root of 5 squared minus 3 squared, Pythagorean theorem, and that's just equal to 4. So it's a 3, 4, 5 triangle. Real quick, I'm just going to note down that I'm just going to call this theta, right? So sine of theta is opposite over hypotenuse, 4 over 5. Cos theta, they already told us, adjacent over hypotenuse is 3 over 5. Tan theta is opposite over adjacent, so 4 over 3. That'll probably be helpful at some point here. All right, so determine sine of 2 theta. So sine 2 theta equals 2 sine theta, which is 4/5, right, times cos theta, which is 3/5. And that equals 24 over 25. So whatever angle this is theta. If you double that angle, then the sine is going to be 24 over 25. The sine of twice that angle is going to be 24 over 25. That's interesting. All right, let's do cos of 2 theta is equal to, well, we could use any one of those guys. Let's do cos squared of theta minus sine squared of theta. And that is equal to, well, cos of theta is 3/5, so cos squared is going to be 9 over 25, minus sine squared, which is 4/5, so it's going to be 16 over 25, and that is going to equal 9 minus 16 is negative 7 over 25. All right, that tells me something interesting actually. So the sine of 2 theta is 24 over 25. I didn't know what quadrant that was in. It could have been over here, where we had, this is 24 and 25, or it could have been over here, 20. I didn't know for sure. So I didn't know if this theta was more or less than 45 degrees to bring it past. But then when I did cos 2 theta, I saw that this one was negative 7 over 25. So this triangle is negative 7, 24, and 25. So indeed, it is in the second quadrant. So this angle that we had originally, theta, is more than 45 degrees because 2 times theta made sine of 2 theta positive, so it was up, but cos 2 theta is negative, so that means it's in the second quadrant. For sine to be positive and cos to be negative, it's in the second quadrant. So that's a cool thing. By the way, I should have known that it was more than 45 degrees because 4 is bigger than 3. And so it goes more up than over. So yeah, I should have known that that was going to bring it to the second quadrant. So tan of 2 theta, I can imagine. I already have this triangle. I already know it's a 24 up, negative 7 to the right. So tan is going to be opposite 24 over negative 7. So tan of 2 theta, I already know is going to be 24, so negative 24 over 7. But let's do it anyway, using our double angles. So tan is this, so let's say tan of 2 theta equals 2 tan theta. So 2 tan theta is 4/3 divided by 1 minus tan squared theta, which is 16/9. That equals, this is 8/3 on top. This is 9/9 minus 16/9, so we're going to have negative 7/9. So that's 8/3 divided by negative 7/9, and it was times negative 9/7, which is, this 3 can cancel with that 9 and have a 3 is negative 24 over 7. And we knew that. All right, let's go to number 5. Determine the values of sine 2 theta, cos 2 theta, and tan 2 theta, given tan theta is negative 7 over 24. Wait a minute, isn't that what we just had? Oh no, we had negative 24 over 7. Okay, so it's going to be a similar angle. So we know it's in quadrant 2, between pi by 2 and pi, and we know that the opposite over adjacent is this has to be 7 because it's got to be positive, so this is going to be negative 24, and this is going to be 25 because 7 squared plus negative 24 squared is equal to 625, which is 25 squared. Alright, so there's our triangle. So I already know that the sine of theta has to be equal to opposite over hypotenuse, 7 over 25. Cos of theta is negative 24 over 25. And tan of theta is opposite 7 over negative 24. This is positive, negative, negative, and that makes sense because it's positive because it's above the x-axis. Cos is negative because it's to the left of the y-axis, and tan is negative because it's the slope is negative. Okay. Now we want to know sine of 2 theta. So sine of 2 theta. Now 2 theta, by the way, is going to be some angle probably in this region. Okay, that'll be 2 theta, right? So this one's short of this angle right here. Theta is short of pi, so this one will be twice as short as from 2 pi, right? So it's obviously not going to get all the way around to 2 pi. Okay, so sine of 2 theta is 2 sine theta, which is 7 over 25, and cos theta, which is negative 24 over 25. That equals, okay, so 24 times 7 is, so 20 times 7 is 140, another 28, so 168, negative 168, and so you get negative 336 over 25 squared, which is 625. Alright, so this angle, it says the sine of that angle is going to be opposite, so negative 336 over hypotenuse 625. Alright, and using Pythagorean theorem, I just did 625 squared minus 336 squared, or negative 336 squared, either way, it works out the same, and that gives me 527. Obviously this is not to scale, considering This side is only 25, but it's the angle that matters anyways, right? So it's the angle that will have that ratio. So this would actually be a much longer stick if it were to go 625. Anyways, so now we know that the sine of 2 theta, we already knew, is negative 336 over 625. And without even doing the rest of the work, I know that the cos of 2 theta is going to be adjacent over hypotenuse, so 527 over 625, so we can expect that. And the tan of 2 theta, I can expect, is going to be opposite over adjacent, so negative 336 over 527. So that's kind of a tricky way to do it even faster than using the double angles, but let's use the double angles because I think that's what we're supposed to be practicing. So cos of 2 theta is equal to, I don't know, let's use the first one. Cos squared of theta. So cos theta is negative 24 over 25, so it's going to be negative 24 squared, which is the same as 24 squared, over 25 squared, minus sine squared theta, so 7 squared, I know that's 49. 25 squared I also know is 625. Let's do that. 625. That's equal. So this is 576 minus 49. So minus 50 would be 526. So 527 over 625. And what do you know? That's what we already knew from before. And let's do tan of 2 theta. That's equal to 2 tan theta, which is negative 7 over 24, divided by 1 minus tan theta, which is negative 7. Oh, tan squared theta, so it's going to be 49 over 24 squared, which is 576. There we go. Alright, so this is going to be negative 7 over 12 divided by, right, this 24 becomes a 12 when it cancels with a 2, divided by, now I've got to get a common denominator here, so this is going to be 576 minus 49, which is 527 over 576, which equals negative 7 over 12 times 576 over 527. And 12 goes into 576 48 times, because 576 is 24 squared. Well, 24 times 24 is the same as 12 times 48, right? Half of 24 and twice 24. And so this is equal to, well, 48 times negative 7 is negative 336 over 527. There we go. And that was definitely the long way around, but of course we got tan of 2 theta, exactly what we expected. How fun. Alright, let's do number 6. Alright, determine the value of sine 2 theta, cos 2 theta, tan 2 theta given. I really feel like we're doing the same thing over and over. This time though we are in quadrant 4, so they're upping the ante a little bit. So let's go to quadrant 4, and we said sine is opposite, so let's call this negative 12 over hypotenuse, which is 13. We already know from past experience this is going to be 5, because 5 squared plus 12 squared is 13 squared. So we already know that sine theta is equal to negative 12 over 13. Cos theta is obviously going to be adjacent over hypotenuse, so 5 out of 13. Tan theta is going to be equal to opposite over adjacent, so negative 12 over 5. Alright, let's go sine of 2 theta equals, so sine of 2 theta, let's just think this through. So this is kind of in the third quadrant already, so it goes 1, 2, 3 quadrants plus a bit. And so if you keep going again, it's going to go 1, 2, 3, 4, 5, 6 quadrants in a bit. So it's going to be somewhere in this range, either the third quadrant or fourth quadrant. So we'll see. Sine is obviously going to be negative, whatever it is. So the sine of 2 theta is going to be negative because third and fourth quadrant is going to be negative. The cos is going to kind of give it away if it's in the third or fourth quadrants. Another thing, though, is we know that 12 is greater than 5. So that means this is longer, which means this angle is closer. So it's actually closer to here. So it's 3 pi by 2 plus only a little bit, not quite halfway. So if we double that angle, it's going to be 1, 2, 3, 4, 5, 6 pi by 2 and a little bit twice. So we are definitely going to be in this quadrant 3 when we do 2 theta. Okay, this is a bit messy. Whoops. Not that messy. All right, so I'm thinking since this right here is theta, I know that 2 theta is going to be all the way around into about here. So 2 theta will be 1 and almost 3/4 of the way around. All right, that's just for our own thoughts to know what the heck we're talking about. All right, and so the sine of 2 theta is simply 2 sine theta, which is negative 12 over 13, times cos theta, which is 5 over 13. So something over 13 squared is 169. 5 times 12 is 60, 120, so negative 120 over 169. Well, that means this angle right here, I can make negative 120, and this is 169. And so let's use Pythagorean theorem to find this, and then we'll be able to check our answers when we do cos 2 theta and tan 2 theta to see if they make any sense. All right, so 169 squared minus 120 squared is 14,161. Take the square root, and it's 119. So this is going to be negative 119 right here. So if that's the case, I already know that cos 2 theta is going to be adjacent, which is negative 119 over hypotenuse, which is 169, and tan 2 theta is going to be opposite, which is negative 120 over adjacent, which is negative 119. These can cancel. The negatives can cancel, so 120 over 119. Again, not stuff we're asking you to do, but I might as well be as thorough as I can so you guys get the best education out of this. All right, we can choose any one of these. Let's do this one this time. All right, so cos of 2 theta is 2 times the cos squared theta. So where's theta? Right here. Cos theta is 5 over 13th. So it's going to be, cos squared is going to be 25 over 169 minus 1. Might as well put it over 169 though. Get a common denominator. So 169 over 169 is 1. So this is 50 minus 169 over 169, which is equal to 119 negative over 169. Let's check over here. What do you know? We were correct. All right, tan of 2 theta. There we go. So we're going to say this, the top is going to be 2 times tan theta. Tan theta is negative 12 over 5 divided by, it's going to be 1, but I'm going to save it. I'm going to get a common denominator here. So it's going to be minus tan squared theta. So negative 12 squared is 144 over 5 squared, which is 25. So here I'm just going to do 25 over 25. Instead of putting a 1, I'll have my common denominator. So this is equal to negative 24 over 5 divided by, so 25 minus 144. So 34, 24, so negative 119 over 25, which equals negative 24 over 5 times 25 over negative 119. This 25 can be a 5. It cancels with that. And this is equal to negative 24 over negative 119, which is 24 over 119. Let's hope that is the same thing. And that is absolutely not the same thing. What did I do wrong? Oh, this negative 24, I forgot to multiply by 5. So we have to multiply that by 5. You're going to get 120. There we go. 120 over 119. There, I saved it. That is a good thing that I did this tan 2 theta over here, because then I found my mistake right away. Okay, I really think that we're going overboard with this. This is the exact same question, except now we have something in the third quadrant. I'm going to go ahead and let you guys do this problem on your own. Like we just did 3 examples. I'm sure you can do this 4th one on your own. All right, here's something new. Number 8, determine the value of a in the following equation. 2 tan x minus tan 2x plus 2a equals 1 minus tan 2x tan squared x. All right, do we recognize anything? I don't see any fractions in here. Let's see what we can do. All right, first things first, we want to know a, so let's isolate a. Okay, so we've got 2a, we'll keep that on the left, is equal to 1 minus tan 2x tan squared x. And we're going to add tan 2x, so plus tan of 2x, and we're going to subtract 2 tan x. So we brought both of these to the right hand side. And then we're going to have to divide everything by 2, but let's clean this up a little bit. So 2a equals, all right, so we got 1 minus, so tan 2x, let's change that. Let's get rid of these double angles right away. We're going to change that to 2 tan x over 1 minus tan squared x. Okay, whenever I see a double angle formula, I like to use, or a double angle, I like to use the double angle formula. This is going to be times tan squared x plus, now we have another double angle. Let's do it again. This is going to be 2 tan x over 1 minus tan squared x and minus 2 tan x. All right, looks like we're going to want a common denominator of 1 minus tan squared x. So we have 2a equals, there's going to be 1 minus tan squared x over 1 minus tan squared x. That's for the 1. Minus, well, this already has, this is 2 tan x tan squared x over 1 minus tan squared x. Keep in mind, for those of you who are shaky with this manipulation, this is all one term. So this is already, when you, this 2 tan x multiplies by tan squared x, and this 1 minus tan squared x multiplies with 1. This is just like times tan squared x over 1. Terms are separated by pluses and minuses, and each term should have a common denominator. Well, this term already is just one term, already has a common denominator. So you're just basically multiplying the top by the top and multiplying the bottom by the bottom. So the bottom stays. There's, just in case you guys were wondering what happened over here, how it's different. The difference is it's not saying plus tan squared x, it's saying times tan squared x. All right, so now we're going to go plus 2 tan x. That's already over 1 minus tan squared x, so no need to change that. And now we have minus 2 tan x. We have to say minus 2 tan x times 1 minus tan squared x over 1 minus tan squared x. We have to get a common denominator there. All right, it's looking pretty complicated. 2a equals, so you got 1 minus tan squared x minus 2 tan, oh, this is tan x times tan squared x. That looks like tan cubed x plus 2 tan x right there minus 2 tan x. I have to distribute this. Plus, so minus 2 tan x times negative tan squared x is plus 2 tan cubed x. And this is all over 1 minus tan squared x. Oh, this is getting fun. So 2a equals, well, this is actually pretty convenient. We've got our 1 minus tan squared x, and then we have minus, we got minus 2 tan cubed x plus 2 tan cubed x. Well, those cancel out to 0. And we have plus 2 tan x minus 2 tan x, and those cancel out. So we're done. It's just 1 minus 2 tan squared x on the top. And that's over 1 minus tan squared x on the bottom. Well, would you look at that? 2a just equals 1. As long as tan squared x does not equal 1. That you have to be careful of, because if tan squared x equals 1, then this bottom is equal to 0. Tan squared x is not allowed, like 1 minus tan squared x is not allowed to equal 0, because if it does, then this is undefined. So 2a equals 1 and a equals 1/2, but only if tan squared x does not equal 1, or we could say 1 minus tan squared x cannot equal 0. And if tan squared x is equal to 1, that means tan, or can't equal 1, that means tan x cannot equal 1 or negative 1, because then tan squared x would be 1. So these are our things. So what is tan x? If tan x is equal to 1, so x cannot be pi by, oh wait, does it say where it's going to be? No. X cannot be pi by 4. That's how tan x would be 1. Or 3 pi by 4. That's how tan x would be negative 1. Or 5 pi by 4. Or 7 pi by 4. And dot dot dot. Oops. Dot dot dot. And at the beginning too. Here, let's erase this. So you really have to put those, x cannot be dot 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 anything pi by 4, any odd number pi by 4. Okay, another way to write that is x cannot be 2n plus 1 pi by 4 with n belonging to integers. So you could say z. So x can't be any multiple, any odd numbered pi by 4. A equals 1/2. All right, and just to see why, because there's no fractions at the beginning, so you're saying, oh, well, why the heck would x not be allowed to be pi by 4 or 3 pi by 4 or 5 pi by 4? So what is it about this equation that makes it that way? Well, just imagine we're trying to find a, and we let x be pi by 4. Well, then the tan of 2x is going to be the tan of pi by 2. But the tan of pi by 2 is undefined. Like it's the tan of pi by 2 is a straight up and down line. The slope is undefined. So that's what happens. And the same thing if it's 3 pi by 4. Well, then 2 times that is going to be 6 pi by 4. And 6 pi by 4 is 3 pi by 2. And again, those are all the places where tan of 2 times x is going to be undefined. And so that's why we end up dividing by something that would make that equal to 0 and undefined, right? So it does make sense that this is not allowed to happen. So as long as x is not one of those that makes this undefined, then a will work as 1/2 and will be an actual solution. Jim needs to find the sine of pi by 8. Hey, Jim, that's me. If he knows that, so if I know that cos of pi by 4 is 1 over root 2, I do know that actually. How can I use this fact to find the sine of pi by 8? And what is my answer? Well, let's see, the cos of pi by 4 is the same as the cos of 2 times pi by 8. Right? So 2 pi by 8 is the same as 1 pi by 4. And the cos of 2 times any angle is going to be equal to, so we can do any one of these. Let's use the top one. Cos squared of that angle, pi by 8, minus sine squared of pi by 8. And we already know, oh heck, let's not do that one. Let's use one that only has one thing. So let's use this middle one. So sorry, I should have said cos of 2 times pi by 8 is equal to 2 cos squared of pi by 8 minus 1. That'll be easier to manipulate. And so the cos of 2 times pi by 8, that's just cos of pi by 4. And we already know that's 1 over root 2. Equals 2 cos squared of pi by 8 minus 1. Now we want to isolate cos of pi by 8. So let's first add 1 to both sides. So we got 1 over root 2 plus 1, but I'll just write that as root 2 over root 2 so I can have a common denominator, is equal to 2 cos squared of pi by 8. So this is going to be 1 plus root 2 over root 2 equals 2 cos squared pi by 8. I think you know I'm going to divide both sides by 2. So I'm just going to put a 2 down here and take it out of there. And now I need to take the square root of both sides. So I'm going to say plus or minus the square root of 1 plus root 2 over 2 root 2 is equal to the cos of pi by 8. And I should have reread the question. We want the sine of pi by 8. So I really should not have used this first one or the second one. I should have used the third one. So I'm going to take all this away and say, start over. We're going to say cos of 2 times pi by 8 is equal to 1 minus 2 sine squared of pi by 8. It's sine of pi by 8 that we want, not cos of pi by 8. Alright, so we're going to say this cos of 2 times pi by 8 is just 1 over root 2 equals 1 minus 2 sine squared of pi by 8. I know I'm going slowly here. Subtract 1 from both sides, so 1 over root 2 minus root 2 over root 2 equals negative 2 sine squared of pi by 8. And we're going to divide both sides by negative 2. And now we're going to take this plus or minus square root of both sides. You have to do plus or minus, otherwise you're going to lose the possible negative answer. Plus or minus square root of, let's say, root 2 minus 1 over 2 root 2. Now I took out the negative from the bottom, but I also switched the top. So root 2 minus 1 is negative 1 times 1 minus root 2. Right? Like 4 minus 5 is the negative of 5 minus 4. If you have any two numbers and you're subtracting them and you switch them, then that takes away the negative. So it's just a little trick here. And that's going to be equal to sine of pi by 8. And now we know the sine of pi by 8 has to be positive, right? So this negative is actually, right, sine of pi by 8 is definitely it's like 22.5 degrees, so it's definitely positive. So this negative is inadmissible. Inadmissible. That is definitely not one of our answers. And so it's simply the root sine of pi by 8 equals the root of root 2 minus 1 over 2 root 2, which equals, I guess I can use a calculator here, and it says that it's equal to 0.38263 approximately. Now just to check, I actually did do the sine inverse of this, and it did give me pi by 8. And I did it in degrees, and it gave me 22.5 degrees, so I know that my answer is correct. Number 10, Marion needs to find the cosine of pi by 12. If she knows that cos of pi by 6 is root 3 over 2, how can she use this fact to find the cosine of pi by 12? What is her answer? I really feel like this is the exact same question that we just did, and so I'm going to go ahead and let you guys do this on your own. Use a double angle formula to develop a formula for sine of 4x in terms of x. Alright, so let's start off with sine of 4x. That's sine of 2 times 2x, which equals 2 sine of 2x cos of 2x, which equals 2, well, sine of 2x is going to be 2 sine x cos x, and cos of 2x is going to be cos squared x minus sine squared x. I don't know if I'm using a good one here or not. I'll figure it out pretty soon if it's not working out very nicely. So this is equal to, we can call this, we're going to take this 2 out, so we can say 4 times sine x cos x cos squared x minus sine squared x. Now we're going to distribute. This is going to be 4 sine x cos x times cos squared x is sine x cos cubed x minus sine cubed x cos x. I actually went farther than I needed to go because we already have something in terms of x here. I don't know why I had to go farther here, but I did. Anyways, this is good enough to me. That was A. Let's do B. Use the formula I developed in part A to verify that sine of 2 pi by 3 is sine of 8 pi by 3. That they're the same. Okay. Well, sine of 8 pi by 3 just equals sine of 4 times 2 pi by 3. And I just said that sine of 4x is going to be this thing right here. Right, so I need to say that sine of 4 times 2 pi by 3 is equal to 4 sine x, so sine of 2 pi by 3, times the cos cubed of x, cos of 2 pi by 3, cos cubed of 2 pi by 3, sine minus sine cubed of 2 pi by 3, plus, oh, not plus, times cos of 2 pi by 3, which equals 4, now let's go over here, sine of 2 pi by 3, that's a special triangle. So this is pi by 3, 2 pi by 3. The sine is root 3 over 2. And the cosine is negative 1/2. So this is going to be negative 1/2 cubed minus sine is root 3 over 2, and this one's cubed, so root 3 over 2 cubed times the cos, which is negative 1/2, negative 1/2, and that is equal to, so we got 4 times root, let's see, 4 times root 3, negative 1 times negative 1 times negative 1, that's a negative, over 2 times 2 times 2 here, that's 8 times 2 again, so, well, 2 of those will actually cross out, so one of those, so this 4 can go away, and I'm going to end up crossing 2 of those 2's out. So 2 times 2 times 2 times 2, so this is just going to be 4 on the bottom. It would have been 16, but I crossed out the 4 on the top, and took the 16 down to 4 on the bottom. And it's going to be minus, all right, this 4 is going to play again. Remember, this 4 is on the outside of these brackets. So the 4 is going to multiply by the first one, but also the second one. So we get 4 times root 3 times root 3 times root 3 is 3 root 3. And negative 1 times negative 1 times negative 1 is negative 1. So this is going to become a plus, negative and a negative. And then we got 1, 2, 3, 4 2's on the bottom, but again, 2 of them are going to cancel with that 4. And so you're going to get a 4 there. So you have equals 3. I'm going to reorder these. 3 root 3 minus root 3 over 4. And 3 root 3 minus 1 root 3 is only 2 root 3 over 4. And that is equal to 1 root 3 over 2. Root 3 over 2. And we want to verify that that is a sine of 2 pi by 3. And the sine of 2 pi by 3, we already said, is equal to root 3 over 2. So sure enough, the sine of 2 pi by 3 is root 3 over 2, and the sine of 8 pi by 3 is root 3 over 2. And we could always have, let's get rid of part of this. We could have easily known that if we just said 8 pi by 3. So this is 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, 6 pi by 3, 7 pi by 3, 8 pi by 3, and 2 pi by 3, 1 pi by 3. Well, this is the exact same angle. Well, one is right here, and the other one is all the way around to here. But the sine is just going to be the height of a dot with a radius of 1. Well, they're both at the exact same spot, so of course it's going to be the same height on both times around. So yeah, it will be the same. Number 12, use the appropriate compound angle formula and double angle formula to develop a formula for sine of 3 theta in terms of cos theta and sine theta. All right, for this question I had to bring in the big guns here. So I've got my compound angle formulas too. The double angle formula is specific, where we have like sine of a plus a. Just to see, sine of 2 theta is just like sine of theta plus theta, right? So sine of theta plus theta. So that would just be sine, you can see that it's just going to be sine a cos a plus cos a sine a, which is just sine a cos a plus sine a cos a. It's the same thing, so 2 sine a cos a. So it's just basically the same formula, but an easier version if a and b happen to be the same thing. Anyway, so let's go sine of 3 theta. Sine of 3 theta is the same as sine of 2 theta plus theta. Right, which equals, now on this one we're going to use our compound angle. So we're going to say sine of 2 theta plus theta is going to be the sine of 2 theta cos theta plus cos of 2 theta sine of theta. And then we're going to use our double angle formula on the sine of 2 theta here. So we're going to say this is equal to 2 sine theta cos theta times cos theta, so I'm just going to say cos squared theta, plus, now I like the second one for this. I'm going to say cos 2 theta is 2 cos squared theta minus 1, and that has to multiply by sine theta, and that's equal to 2 sine theta cos squared theta plus, so we're going to multiply each one of these, so it's going to be 2 cos squared theta sine theta minus sine theta. Now I did that purposely because these guys now match up, so this is equal to 4 sine theta cos squared theta minus sine theta. And if I want to go a little farther, I don't know which one's nicer. This is probably the best one, but we could take out a sine theta. So we can say sine theta times 4 cos squared theta minus 1. Now don't be tempted to think that that's the same as 2 cos squared theta minus 1. If you did that, this 4, you'd have to bring out a 2, but then this would become minus 1/2, which wouldn't coincide with that anyway. So we're as far as we can go here. Part B, we're saying cos of 3 theta. So we're going to say 2 theta plus theta. All right, so that's going to be equal to, well, cos of 2 theta plus theta is cos of a plus b right here. It's going to be cos of 2 theta cos theta minus sine 2 theta sine theta. And that is equal to, well, cos 2 theta. I don't know, let's use this one again. Maybe it's not a good idea, but we'll see. This is going to be 2 cos squared theta minus 1, and that is times cos theta minus sine 2 theta. So it's going to be 2 sine theta cos theta times sine theta, and that equals, so this is 2 cos cubed theta minus cos theta minus 2 sine squared theta cos theta. This one doesn't seem as nice as the other one. I can take a cos theta out. So we can say cos theta is 2 cos squared theta minus 1 minus 2 sine squared theta. I probably used one. I probably could have done better with if I had used a different one, but we did the job. This is still a formula for in terms of cos thetas and sine thetas, so we're good to go. Part C, it's not going to be any different, guys. We just do the same thing as what we just did there, but we're going to do it with tan, so I really don't think I have to do that one. You're all good to go. Number 13, the angle x lies in this interval, so this is second quadrant, and sine squared x is 8/9. Without using a calculator, determine the value of these things. All right, let's set it up here. We know we're in quadrant 2, and we said that sine squared of x is 8/9. So sine of x is the square root, is equal to the square root of 8/9 plus or minus, but we know that sine x has to be positive because it's in quadrant 2. So it's just going to be the plus. So 8/9, so that is equal to root 8 over 3. Root 8 is just root 4 times root 2 over 3, which is 2 root 2 over 3. Okay, so we can say that's sine x. This is going to be opposite, 2 root 2 over 3. And what is this going to equal? So this is going to be 3 squared minus 2 root 2 squared by Pythagorean theorem. So this is going to be 9 minus 2 root 2 squared is 4 times 8, so 8, and this is just equals 1. So let's erase all that. We can say this is 1, 2 root 2, and 3. So the sine x is 2 root 2 over 3. Cos x we can do is, this is going to be negative 1, by the way. Negative, because it's on the left hand side, 1 over 3. And tan x equals opposite over adjacent, so 2 root 2 over negative 1, so negative 2 root 2. All right, the angle x lies in that area. We got that. So we found out what sine, cos, and tan are. So sine of 2x, which is just equal to 2 sine x cos x, which equals, right, so sine x is 2 root 2 over 3. So 2 times 2 root 2 over 3 times cos x, which is negative 1/3. Negative 1/3. So this is equal to negative 4 root 2 over 9. There you have it. And cos 2x is equal to, let's see, cos 2x. Let's do this one. Cos squared x minus sine squared x. So cos squared x, so cos x is negative 1/3, so cos squared x is positive 1/9. Negative 1 times negative 1 is 1. 3 times 3 is 9. Minus sine squared x. So sine x is 2 root 2 over 3. So 2 root 2 squared. 2 squared is 4. Root 2 squared is 2. So this is going to be 8. Well, 3 squared is 9. So cos 2x is going to be negative 7 over 9. And cos of x over 2 is equal to, well, this one we're going to have to go the other way around. So we know that cos x is equal to cos of 2x over 2. It's the same thing, and that is a double angle formula. So we can say cos of 2x over 2 is cos squared x over 2. Oh, let's keep it as just a cos or a sine here. So don't use the one with cos and sine. Okay, so let's say 2 cos squared of x over 2 minus 1. Right? And we know that cos x equals negative 1/3. So negative 1/3 equals 2 cos squared x over 2 minus 1. I'm going to need more room, so I'm going to go up here. So negative 1/3 we have equals 2 cos squared of x over 2 minus 1. We're going to add 1 to both sides, so it's like adding 3 over 3. So we're going to have 2/3 equals 2 cos squared x over 2. Divide both sides by 1, or by 2, sorry. So this is going to be a 1, and this is going to be a 1. And then you take the positive or negative square root of both sides. So plus or minus root 3 equals cos of x over 2. Now we do know that x lies somewhere in the second quadrant, so somewhere between pi by 2 and pi. So half of x is going to be half of that. So the most it could be is pi by 2, and the least it could be is pi by 4. So it's going to be somewhere in this region. So it is definitely, the cos is definitely going to be positive. Right? So over here, when we said plus or minus, we know it's going to be the plus part of it. So that's it. Cos of x over, cos of x over 2 is equal to root of 1 over 3. Or we could actually say cos x over 2, you can say, is equal to 1 over root 3. It's root 1 over root 3, but root 1 is just 1. All right, that one was fun. Let's do part D, sine of 3x. So sine 3x is equal to sine of 2x plus x, which equals, let's see, sine of a plus b. So you're going to say sine 2x cos x plus cos 2x sine x, and that equals 2 sine x cos x, that's for sine 2x, and that is times cos x, so we can say cos squared x, plus cos of 2x. I never know which one to use. Let's go cos squared x minus sine squared x. So cos squared x minus sine squared x, and that is times sine x. Now let's just fill it in. That's equal to 2 sine x, we already know, is 2 root 2 over 3. Or we could just say root 8 over 3. It's probably nicer. Root 8 over 3. Cos x is negative, is that cos, is it negative 1/3? Yeah, negative 1/3. But square that, and you got 1/9 plus, open bracket, so you got cos squared x again, that's going to be 1/9, minus sine squared x. So sine x is root 8 over 3, so sine squared x is 8 over 9. And multiply that by sine x, which is root 8 over 3. So I'm running out of room there because I've got something in my way that you guys can't see. I've got like a menu at the bottom here that's in my way. Alright, so I'm going to go back up here. So 2 times root 8 over 3 times 1 over 9. The bottom looks like it's going to be at 27. And I'm going to have 2 root 8 at the top. And that's plus 1/9 minus 8/9 is negative 7/9 times root 8 over 3. So that's going to be equal to 2 root 8 over 27 minus 7 root 8, both over 27, which equals 2 root 8 minus 7 root is negative 5 root 8 over 27. That root 8 is kind of weird. That's root 4 times root 2. So this is going to be negative 10 root 2, because root 4 is, right, so root 8 equals root 4 times root 2, which is just equal to 2 root 2. So negative 5 times 2 root 2 is negative 10 root 2 over 27. There's your answer for sine of 3x. Now you're probably wondering how the heck you would check that answer, because I did a lot of math there. I could have easily made mistakes. So I am going to check that for you. Let's see what we can do to check that. Alright, so we know that sine of x is in this second quadrant over here. Right in here. And it was sine squared of x, so it is root 8 over 3, like that. So if I take the sine inverse of root 8 over 3, keeping in mind that it has to be in the second quadrant, and my calculator will probably give me an answer over here. So that is going to be equal to, approximately 1.231. I'm going to keep that whole number in my calculator though. So that's the angle that it says, but that can't be. That's in the first quadrant, that 1.231. So I'm going to do pi by 2 minus that. That gives me 0.339836909, whatever it is. And I'm going to take that answer, so that's whatever this is right here. I'm going to take that answer and I'm going to add it to pi by 2. So my new answer is actually 1.910633 approximately, and this was not the correct answer because it was in the wrong quadrant. So this is my actual angle. So if I want to know 3x, I'm going to take that number, I'm going to multiply by 3. And the sine of 3x, I just have to take the sine of that and see what I get. So sine of that, and I get negative 0.5237828008789. Really didn't have to write all those digits. And now let's just check. I'm going to multiply that by 27. And that should be negative 10 root. If these are equal, then when I multiply by 27, I should get negative 10 times root 2. Okay, and then I'm going to divide by root 2, and I should get negative 10. So divided by root 2, and I get negative 10. Yay, so that really is the correct answer. And you can use that same strategy, of course, to check your cos of x over 2. So we did find this was my x. If you keep that full number in your calculator, you could just divide it by 2, and you'll know that what the x over 2 is. And then you take the cosine of that, and you see if your answer is the same as the one we got. Again, we have our x. If you multiply by 2, now you're going to know 2x, and you can take the cos and see if that part B was the right answer. And you could do the same by multiplying by 2 and taking the sine, and you'll know if part A was the right answer. So you can always check your answers and you always know if you got all the right answers.